So you have done the simple trigo identities. Now is for the more challenging and more fun, advanced trigo identities. Okay, so this before we begin, always start with writing down the equations. 1 over sine x, sine, the other one cosecant x, 1 over cosine secant x, okay, 1 over tangent cotangent x. Okay, next sine square x plus cosine square x equals to 1. So if you divide throughout by cosine square x, you get 1 plus tangent square x equals to 1 over cosine square x. So from here it will be secant square x divided by sine square x, 1 plus cotangent square x. Okay, divide by sine throughout will be cosecant square x. Okay, let's double check. Divide by cosine square, divide by cosine square, divide by cosine square. Okay, so after that we can start solving. This is a long, complicated equation. Has to be advanced questions. Okay, copying this down already is quite tiring. Like I said before, trigo identities are the simplest to work with. No need to worry about asymptote, no need to worry about angle, no need to worry about range. Just look for patterns and work your way to your final answer. So the only thing you waste is your pen ink, a bit of time. Yeah, but it's fun doing this. Love trigo identities. Okay, so you can see we have something complex. You work out to a single number. Seems impossible, but can be done. Okay, over here, we don't straight away expand everything. We always try to factorize. From something complicated to something so simple, expanding will not help. It's only through factorizing then you can get the simple form. And also look for patterns. So here, I got a sense that, you see, 1 plus something, here a plus, here is minus. So I see, in my gut is telling me this. A square minus b square is a plus b, a minus b. So can you see this? A plus b, this is the a term, minus b, this is b term, a term, b term. Okay, this is simple. We are trying to make this into this simple form. So let try to follow my gut first. We can always try and error. Working on trigo identities is all about trying. Don't try, you get stuck. So once you try, you know that this method won't work, you can try other things. Now, this is, let's say this I assume to be A. So let's change. Okay, let's say I make this A. I'll make this B. I need to change this to become something like A and make this something like B. Okay, that's my aim. Okay, so in order to make it something like tangent x, here cotangent x we know is 1 over tangent x. Okay, we might need to multiply. Here we need to multiply, here we need to multiply tangent square x so that we can have tangent x. So let's say I multiply tangent square x, and so 1 of the power will remain is tangent x. Okay, then I try to look at 1 times tangent square x. It doesn't have anything equivalent on this part. So I should multiply tangent x instead. Tangent x times this, or I'll get back this. So whether will I get back 1, I believe I will, because tangent times 1 over tangent x will give me 1. So I think that will work. So let's try. I'm introducing tangent into here. So later I need to divide by tangent to make the equation balance. Tangent x minus secant x. This I keep. So 1 over, oh sorry, here we multiply tangent x, I forgot. Okay, multiply tangent x. Here multiply tangent x will become 1. Cosecant x multiplied by tangent x. Okay, because we have multiplied tangent into this, we need to divide by tangent by x. Okay. Just in case you can't see it, might as well write this down. Tangent x. Tangent x. Okay, I'm trying to multiply tangent x into this term here so that it has the equivalent, so that I'll get my a and b to work out the algebraic identity. Okay, so I can see that this is my a. Will this become my b? I don't know. I need to work it out. So let's try. Maybe oops, what did I do? Okay, let's step back. Oh, it doesn't work. I don't know what did I erase, but never mind. Erase this. Write this somewhere else because no space. Square minus b square. A plus b. A minus b. Okay. So this is some idea I have to reduce to this form, and hopefully get to. Okay. So there's more than one way to solve this. This is just one of the many ways. So if you have better solution to this, yeah, you can do them, no problem. Cosecant, okay, will be 1 over sine. Tangent is sine over cosine. Okay, don't forget, here I should be putting a big bracket, because inside it I already used the round bracket. Tangent x outside. Okay. Here, if I cancel off sine and sine, I'll see that 1 over cosine x is equivalent to secant x. So my gut feeling has made me change to this form. So since this is my a, so a square minus, okay, this and this are the same. Okay, if you need time, pause, rewind, compare, work it out on piece of paper. Okay, it's a must to practice this. Secant square x. So am I 1 over tangent x outside? Okay, now seems difficult, but here I look at my equation, my identity, I have secant square x. I can change to this form, and it will minus away, it will form something nice. Okay, before that we need to expand this. Okay, 1 plus 2 tangent x plus tangent square x. Okay, this and this will give me secant square x. Later on you'll see how the magic works. So the fun about trigo identity is the magic will come in if you persevere through your working. Okay, so 2 tangent x plus secant square x, because 1 plus tangent square x. Okay, pattern, okay. So this will miraculously cancel away to form 0. Tangent x cancel will become 1. Therefore, voila, proven. 2. See the beauty of it? Wow. Okay, so let's try another one. Next. Okay, let's try this. Always start with the complicated side, left hand side. This is so complicated. Fractions some more. So whenever we see fraction, first thing is to combine into a single fraction to simplify things. So the reason why we combine into a single fraction is we want to simplify our things on the left hand side because it's so complicated. Okay, secant x minus 1. Yeah, some of you must be wondering, hey, how come the handwriting sucks? Because this is PowerPoint and not pen and paper. Pen and paper, my handwriting is better than this. Okay, so here we can combine. X minus 1. So sine x, we multiply by this. Okay. Try to simplify the numerator. So I take out my sine x. Simplify, I always like to factorize out. I don't like to multiply in because we want to make this simpler and not make it more complicated. So I'm left with secant x plus 1 plus secant x minus 1. Okay, the bottom part, why did I not change to the a square minus b square is because, again, I want to leave it in the factor form so that I can reduce this to a simpler form. Okay, so here you can see that 1 and 1 cancel. Sine x. Okay, here no need to panic. Okay, from here we can see that it's quite simplified, but we are still not getting the cotangent. So now we need to think of another way to get near cotangent. Okay, so here I know that I need to change to 1 over cosine x because sine divided by this will give me tangent. So I'm nearer to cotangent. Over here, I might need to change and expand this because I remember the identity of 1 plus tangent square theta equals to secant square theta. So we might need to get nearer to cotangent by changing everything to tangent. Okay, so let's do this. 2 sine x secant equals sine x. So this is the a square minus b square. So secant square x minus 1 square. So 1 square is actually 1. Okay. So the top part is 2 tangent x. Bottom part, if you can recall, 1 plus tangent square x equals to secant square x. Here is secant square minus 1, so I bring this over, will become minus 1. Is equivalent to tangent square x. Okay, now you can see that, oh, nice, can cancel off. Okay, 1 over tangent is cotangent to cotangent x. And we have solved this. See, the magic will only come towards the end, so we must persevere. Okay, try to work towards something close to it, and you'll get the answer. So let's work out the next one and the last one. Yeah, I believe by now there's some pattern that you see. Always factorize and change the terms to the trigo that is near or similar to the one on the right hand side. Okay. Oh, my handwriting is really bad. I wish I have better software, but freeware are like this. Okay, here again same thing, factorize, take out the 3, don't care, just do it. You'll see some magic later. Okay, sin x, cosine x. Okay, here you notice very similar. It has a 2 cosine square x. Okay, I'm looking at this. I try to get to here. How? This is in a fraction form. This is a linear form. I might have to think of way to get rid of the denominator to change to this. I might want to replace the cosine square with sine square, but that's not necessary because here there's cosine. So I noticed that there's a 1 minus 2 cosine square x. This, my gut tells me, is something like a square minus b square. Something similar. 1 square could be the a, this could be the b square. So I want to keep this. I want to make this something like a square minus b square. I don't know whether I'm doing this correctly or not. Just try. Okay, there's no harm trying. Okay, once you do the denominator, you have to do the same for the numerator. Oh, my handwriting is really, really bad. Okay, pardon my handwriting. Okay, now, sorry, this is plus. So we work out the denominator first. Keep the numerator on hold. I just want to see some pattern at the denominator first. Okay, my drawing tablet is the cheapo kind, although it's still very expensive, but it's the low end class, so kind of not so smooth in writing. Okay, sine square x minus cosine square x. Okay. So I look at this, I see something already. I see a pattern. This sine x plus cosine x is here on the right hand side. The 3 is also on the right hand side. So maybe I just rewrite that first. Okay, my gut is telling me I'm getting closer and closer to my answer. Oh, my PC is lagging. Too much math. It cannot take it anymore. Okay. Oh, forgot the denominator. Yup. PC going down. So I know this is what I will end up. I need to keep this. Somehow this and the denominator has to cancel off, so that I will get this. So obviously sine square x change to cosine square x. So recall sine square theta plus cosine square theta equals to 1. So sine square is just bring cosine square over. Okay, there's nothing wrong with your PC quality. It is my comp that is lagging. It is my drawing tablet that needs some improvement in quality. Okay, sine square x is bring cosine square over 1 minus cosine square theta. Okay, minus cosine square theta. Wow, this is really bad. Oh. Okay, bear with me, we are getting there already, huh? We are getting there. So you can see 1 minus 2 cosine square theta. Oh, sorry, should be x. So when you do your working, please check. I think this is the only mistake you ever made in trigo identities. Other than that, it should be getting answers all the way. So here we can cancel off. Yes, you see, the magic always comes near the end. So must persevere, don't give up. Okay, proven. The word proven is must, to show that your working has ended and this is the final answer. Okay, all the best in your exams.